All right, so good morning, everyone, or maybe good afternoon or good evening, depending where you are today. Welcome to our Q&A session live on YouTube, directly from Montreal, Canada. My name is André Tétreault, and I am Director of the Test and Diagnostics Division here at VibroSystM. And I have with me my colleague, Mr.Bernard Lemay, who is one of the analysts for the Test and Diagnostics Division.
Good morning, André.
Good morning, Bernard. And Bernard will be handling all the logistics this morning to make sure the questions are logged and read so that we can answer as many questions as we can. In reality, the Q&A session, and we decided to do a Q&A session because, 6 weeks ago, we held a 3-day webinar on hydro generators, and there were quite a few people that attended, and there were many questions, and unfortunately, some of the questions, or many of the questions, we just did not have time to answer. So we felt maybe it would be a good idea to hold a Q&A session, cover the questions that we didn't have a chance to answer, cover the questions that were answered but were very interesting, so I guess it would be beneficial to everybody to get the answers to those questions. So here we are. For those who are not very familiar with VibroSystM, just a brief history. VibroSystM was founded in 1986, so we've been working in this industry for 34 years. Basically, initially the company came out with the first air gap monitoring systems, but through the years, as you can imagine, we've added a whole list of measuring chains and techniques and acquisition units and software, and eventually a test and diagnostics division. So the company has been in the field of monitoring, offering monitoring solutions for 34 years. Although we began in the hydro industry, we've been in the turbo industry for over 25 years, and we are also involved in the mining industry. So basically any industry that has large rotating electrical machines, we have solutions to help customers better manage their assets. From my point of view, I joined the company 25 years ago, initially as a field engineer, so I had the opportunity to travel the world to install these equipment. Gave me the opportunity to, especially in the hydro field, the variety of different units, different power stations. It's very rare to see two hydro stations that are very much alike. I think the only ones that you can actually see a similar layout is when you go to pump storage units. You will find some power stations that are similar, but in most instances, they're very unique and very interesting. I did that for about 5 years, and then the company decided to merge the technical support department and the software development department into one department, which I was asked to lead. I did that for 10 years, and during that period, I was also responsible, or I guess liaison, with our expert, who was a member of Hydro-Quebec, well-known gentleman who spent his entire life analyzing hydro generators mostly. And I spent the better part of 6 years working with him to make sure the quality of the data was correct, that his reports were translated in English, and I got a chance to learn a lot from this gentleman. And at some point when he retired, I picked up the ball and decided to start doing my own analysis for this department, and I've been doing that for 15 years now. In 2010, the workload was such that it was impossible for me to keep managing 3 departments, so we decided to create the Test and Diagnostics Division in 2010, and I've been leading that department ever since. We have a team of analysts, of developers, working on different tools, basically in some instances to be able to feed our Zoom Watch platform, which is a service that we offer our customers, to be able to crunch all the data and put it on the website. So we have a whole team working on analysis of data, developing platforms, and trying to get the most out of the systems for our customers. The role from our department is, well, first and foremost, is to offer the expertise to our customers. Second is to provide training courses. We give data analysis training courses, again, hydro, turbo, and in the mining industry. We also publish papers to try to disseminate as much information as possible at various conferences. And last but not least, we participate in international committees like IEEE, IEC, CGRE, EPRI, all these different associations. Again, try to give back to the industry what we know about monitoring generators. So the question today was to, again, take questions from the people who are connected. Although the webinar was for hydro generators, we invite all questions for turbo generators as well, although the units are very, very different. In some instances, they're very similar. So we have the expertise for that, and hopefully if you do have questions, we'll be able to give you some answers. All right, so do we have any questions, Bernard, so far?
Not so far.
Not so far, okay. Well, one of the questions that was asked during the webinar is, well, in fact, one of the factors that we see quite often, and we talked about that in the last video we showed on YouTube. During all my travels, I've discussed, of course, with engineers from manufacturers, from utilities, the impact of having monitoring solutions in your power plants. And in some instances, or in many instances, I get the comment from utility engineers that although the technology is very interesting, they find it fascinating, they'll tell me that it's difficult to justify at their power station because their units are fairly small. And I always tell them, well, I mean, if your unit goes down for like 6 months and it costs $2 million to fix, if that's not a problem for you, no, you don't need monitoring. And when I say that, they all respond with the same answer, no, these units are critical to the operation of our company. So I always say, well, why are we talking about megawatts then? I mean, the issue is not megawatts. The issue is how critical is this asset to you. If you have a 800 megawatt unit, and if it fails and it goes down and that doesn't cause you a problem, you don't need monitoring at all. You just fix it. But we know that's not the case. So if your asset is critical to you, and 99% of the time it is, you do need some monitoring. Now, what type of monitoring? Well, that depends on existing issues with the unit, known issues with similar types of units, evidence of problems during commissioning or during the inspection during outages. There's various reasons why you should pick such type of equipment or that type of equipment, and we can help with that. So that's one of the questions that was asked, or it was maybe not a question, but more a comment, and I get that comment quite often. So, do we have any questions?
Actually, we do have a question. Someone asks if it is required to calibrate sensors as per different generators' ratings and their problems. So.
Well, you don't need to calibrate sensors based on the unit or the parameter. You do need, depending on the type of sensor or the vendor, some sensors do not require calibration, some do. For example, we produce high-quality capacitive probes for, let's say, shaft displacement, and those are capacitive. So they don't create a magnetic field, they create an electrical field, and those sensors do not need calibration. It doesn't matter what type of material is in front of it, so long as it's conductive or semiconductive. It could be rusted, it could be scratched, it makes no difference whatsoever. The performance is the same. While inductive probes, we're using eddy current technology, those have to be calibrated because they are very sensitive to the type of material. So if you put an inductive probe facing steel or iron or chrome or aluminum or brass or any combination thereof, chances are you will have a different response, and you need to find out what that response is so that you can configure your system properly to get the good result. So if you have a certain amount of current that is generated by the sensor, you need to know what that current represents. And in fact, in most cases, if you don't calibrate, which unfortunately many people don't because they just are not aware that this is a consideration, the vibration readings will actually usually be less than what is actually the case. So it is important. Inductive probes work very well as well, but you do need to know this and calibrate it properly so that the readings you get are correct. Any other questions?
Yes, Andre. We have Jose here who wants to know if we have case studies where the monitoring was used to prevent forced outages.
Oh, we have quite a few of those. In fact, I've been giving training courses on data analysis for, 15 years now? And the training courses that I give, which are usually 3 days, if there's automatic translation, it turns out to a 5-day course. But during the 3-day course, we have a whole list of case studies that are based on real data, real problems that occurred while we were testing. Issues with rotor rims that were just about to come off, loose poles, axial displacement causing thrust guide bearing failures, turbines which are hitting the discharge ring, stators that do not behave according to tolerances, new stators. There's a whole list of case studies that have shown not only picking up very important things during the commissioning, especially if it's a new unit. You'd like to find the problems during the warranty period, not after the warranty is expired. And also a whole bunch of issues that are trended, that you can see that evolve very, very slowly, giving you some tips or some information as to what the problem is. A very famous example is in the northwestern United States. There was a major refurbishment, I believe it was 8 units, very large concrete dam. And they had issues with their stators before they did the refurbishment project. And when they commissioned the first unit, the units were fine, but within 3 or 4 months, the stator would seriously distort, way beyond what their tolerances were. And they couldn't find out what the issue was. The OEM was on site. They were checking everything, the cooling system, the sole plate system, the greasing, all the different parameters. Couldn't figure out what the issue was. And in reality, the problem lied with the concrete. It's a common issue, especially in the northern hemisphere, where the seasons will cause the concrete to expand or to contract. So in the winter, the concrete will contract because of the cold weather, cold cooling water, and in the summer, the concrete will expand as everything heats up. And that expansion contraction was causing the stator sole plate positions to change, causing the stators to distort. And they were able to pick this up because looking at the trending data, which is very slowly evolving data, they could see the shape of the stator evolve over, let's say, a year. And they were able to use the data from the monitoring system to be able to, I guess, calculate the rate of expansion contraction to try to calculate the best optimal position or shape of the stator depending on what time of the year the stator was installed. So they tried to mitigate the difference between the two seasons, trying to put it in an optimal. And in fact, in some cases, they actually installed a stator somewhat distorted, anticipating the expansion and contraction rate. And it was the best way that they could find to manage this issue. So there are quite a few cases. I've written maybe, 20 papers on different phenomena, different issues, hydrogenerators, turbogenerators, and also on large sag mills and ball mills in the mining industry. So we have a lot of literature on these cases, yes. Any more questions, Bernard?
Yes, André. We have a viewer who wants to know what about smart sensors that measure vibration and temperature in continuous monitoring?
Yeah, that's in fact we have ourselves developed a sensor that allows you to monitor the velocity, for example, of stator bars as they exit the core, or if you, well, not put it in the windings, but a small digital sensor that allows you to measure the vibration in multiple axes and also give you the temperature. And the reasoning for that is that usually people will put RTDs to measure the temperature of the bars, trying to detect any deterioration of the insulation over time, which should generate heat. Of course, the insulation, if there's a lot of vibration, the insulation will deteriorate, and that will hamper its capacity to dissipate heat. So the heat will get trapped, it's not dissipated as efficiently. And if that's left unchecked for some time, you can have a significant failure, or best case, you will have a winding that's in bad shape. But if you measure the temperature, or in some cases, people will monitor with partial discharge, trying to detect partial discharge between the insulation and the core. That's fine. But if you do have high PD, or if you have high temperature, the problem is that the damage has already occurred. And our philosophy has always been to detect issues to prevent damage, not to install the equipment to observe the damage. So with a velocity transducer, and a temperature signal as well, you can monitor quite a few hundred bars simultaneously and have a picture of how much vibration is present and what the temperature is. And you can correlate certain bars that might be vibrating more and the temperature might be a little higher. So it allows you to go in there and apply corrective measures to ensure the long-term working condition of the bar, instead of just observing the fact that there's damage on the bars and they need to be replaced. Any more questions?
We actually have a couple more questions.
Okay.
Another viewer wants to know what are the most important features to monitor in a turbogenerator rotor.
The best tool that is available for the rotor, and I guess that's despite the fact that, of course, if you have an issue with the rotor, chances are it will show up as shaft vibration. And we know that turbogenerators at those speeds, 3,000 or 3,600 RPM, you can't afford to have high vibration levels at the shaft. Hydro is much more permissive. I mean, we can have higher vibrations before damage occurs, but at 3,600 RPM, you can't afford to do that. I guess the best tool that's available is stray flux probes. Historically, people, what they would do is they would suspect they had shorted turns when, if they increase the load, if they increase the excitation, the unit would start to vibrate. The second thing is that if they had to produce VARs, they would find it would take more and more current to produce the same amount of VARs. And these were all signs that you had some shorted turn issues on the rotor. Today, you have tools that allow you actually to see the signature or the magnetic flux profile, not only of the poles, but of each individual coil, in an attempt to detect coils that are not producing the same amount of flux as the others. And by doing that, you can detect exactly, or more precisely, where the short is. Because the problem is that if you think that you have shorted turns and you stop the unit and you do a test, an offline test, the conditions might not be the same. That short might not be there when the unit is cold. So it's very difficult to find out where the short is. So if you have online data telling you exactly that your issue is at coil number 5 on pole B, well, then you can, when you stop the unit, you can focus your efforts on that location and try to find where the short is. Any more questions?
Yes, Andre. We have another question from Mark, who wants to know if air gap sensors need to be calibrated.
No, they don't. I mean, they have to be installed properly, which is why when we have new customers, for example, if they have 5 generators, and the utility or the OEM wants to install it themselves, that always makes us nervous, because when you know how to install them, it's very simple. But there's one or two ways to do it correctly. There are a million ways to do it incorrectly, and you have to realize that these sensors are installed in a very hostile environment. There's very high flux involved. There are high temperatures potentially involved. There's a lot of EMI on these machines. It's very easy to do the cabling incorrectly. You'll pick up noise, and you'll wind up trying to measure noise instead of measuring the air gap. No, they do not need to be calibrated, but you do need to know the recipe to install them correctly. So, which is why that when we do have contracts with multiple units, we strongly recommend that we do the installation. If that's not possible, for whatever reason, we strongly recommend that the utility or the OEM allow us to install the first unit so we can show how to do it correctly, to make sure that whoever does the installation afterwards will do it correctly, and it won't cause any issues to the system, it won't cause any issues to the generator, and more importantly, it won't be a safety risk for personnel working on the unit. I had a question that was given to me. Some questions were close to that subject during the webinar, but there was a question afterwards asking me, what's the big deal with mechanical centers versus magnetic centers? That's an issue we see quite often, and in most cases it's a condition that is not picked up by utilities or OEMs, simply because if you have a rotor that has a mechanical center which is different than the magnetic center, which means that when the unit rotates normally without any field, it will pick a position, a center position, and it will rotate around that axis. But when you apply the field, it will shift position, and it will adopt a different position. And that is caused by a rotor that's not centered from the outset. If you start the unit and the rotor is not centered related to the stator, which means there's a smaller air gap on one side and a larger air gap on the other side, when you apply the field, for sure the unit is going to be pulled towards the smallest air gap, because that's where the strongest magnetic field will be. And it will stay in that position so long as the field is there. Now, the reason why this is a sneaky thing is that usually people will look at the vibration panel, and they will see that when the unit's at full speed without excitation, the vibration is usually a little higher, because there's nothing really holding it in place. I mean, there's only the hydraulic forces and centrifugal forces. Nothing is coupling the rotor, so it usually has a higher vibration. But when you apply the field, since the rotor is then pulled into one direction, it is magnetically coupled, and it is held there in place by the magnetic forces. So the vibration, the peak vibration of the shaft will decrease, sometimes significantly, leading people to believe that the unit is in good shape, because once it's excited, the vibration goes down, everything is nice. But in reality, you have an issue, because the rotors are not designed, and the stators in fact, are not designed to operate with varying magnetic fields. It's supposed to be a symmetrical, stable magnetic field. But if you have this situation, for example, if you take rotor poles or the rotor rim, as it rotates, when it's at the smallest air gap, magnetic field is much stronger, so it's pulling much harder on all the components than what the rotor was designed for. But then when it rotates on the other side, it has a much weaker magnetic force because the air gap is greater, so the stress is much less. So as you rotate, you're subjecting all the components of the rotor to a varying magnetic field. So it is solicited at various forces, and that's the best way to create fatigue, metal fatigue of all the components. If you subject them to a varying magnetic field at each rotation, they will have a tendency to deteriorate much faster. And if nobody does anything about it, the first time that you'll notice there's any issue is when the unit fails. And we've seen poles come out before rotor rims come off. We have a very famous case in Brazil many years ago where there was a rotor stator rub early on one of the units that had not been equipped with a monitoring system yet. And when I went to site, we made sure all the units were monitored. And when we did testing on one unit, we found a severe problem on one of the on that unit on the rotor rim, and we could clearly see as we were increasing the load, there was an entire section of the rotor rim that was coming out. And in fact, what we did is we found exactly what had happened on the other unit. That rim came off and actually hit the stator. The unit wasn't even a year old. Okay, so when you create an uneven magnetic field, you solicit the rotor and also the stator to conditions that it's not designed for. Okay, it causes issues to the rotor. If the delta between the mechanical center and magnetic center is sufficiently high, the unit will actually tilt on one side, and it's going to apply a lot of pressure on the bearing as well, and eventually it might cause a bearing failure. And for the stator, well, the stator, where the air gap is small, is being subjected to a much higher magnetic field than what it's designed for, and that can cause heating of the core. It can cause excessive stator bar vibration, deterioration of the insulation. It can cause all kinds of issues to the stator that, again, the units are not designed for this. So how long the units last, that's impossible to tell, but if you have a brand new unit and you have this situation, I think it's a good thing to tell the manufacturer that that's not acceptable. Any more questions?
We have a question for from a viewer who wants to know regarding capacitive type proximity measurements. What is the effect of oil if it is present on the surface of a bearing casing?
Okay, it depends. If you have a nice even film, which in some cases, the units that have oil, that's the case. They have a uniform film of oil all around the shaft, and if that's the case, it makes no difference. I mean, you might have a small offset in the actual gap between the probe and the shaft, a small one depending on how much oil it is, because the oil changes the dielectric properties. The sensors are calibrated for air. So if you have a small film of oil, it will have a difference, but it will have no impact whatsoever on the peak vibration, which is what you're looking for. Inductive probes are very sensitive to magnetic runout. They're very sensitive to properties of the shaft. They're very sensitive to scratches, deterioration, rust, things like that. But they are not affected by oil films or oil streaks. Capacitive probes, if you do have oil streaks, if you have uneven distribution of oil around the shaft, then the capacitive probe may not be the best choice. You should use an inductive probe in those cases. But in most cases, the capacitive probe is a better solution simply because, again, there's no calibration and there's no conditioner. Most places, you install a sensor, you gap it with a filler gauge, and you connect it to your acquisition unit, and you're ready to go. And you're not worried whether the calibration is correct. There is no calibration. It is correct.
We have an interesting question here regarding partial discharge.
Okay.
Someone wants to know if we offer online PD monitoring for stator windings, and if yes, then how do you classify the PD pulses in their severity?
Yes, we do have a partial discharge monitoring system. We have quite a few complementary systems that we provide. Although my personal view, I find partial discharge very interesting. The science of it, the technology is interesting. But if I had no monitoring on my unit and I had to spend some money, partial discharge would not be in the first 4 or 5 systems that I would buy. For me, the return on your investment, there are many other technologies that will help you determine immediately if you have issues. The problem with partial discharge is that it's a trending technology. It's quite common to have partial discharge very high on a brand new unit. And it's normal because the epoxy hasn't completely cured yet. The stator bars haven't settled in their final position. They haven't taken their position in the slots. There's all kinds of reasons why the partial discharge may be high and will go down, let's say, over a year. Some units have very high PD for 20 years. In fact, the only thing that you should look for is whether there's a change. If you see a change in the partial discharge, that is not supported by a change in the operating condition of the unit, whether it's load, humidity, or contamination, or whatever. If you see a change that's not supported by a change in the operating condition, that should be a sign that you have an issue. However, that is in the long term. For me, partial discharge is a tool to try to assess the overall health of my windings, the overall health of the insulation. And if I see a serious deterioration, it helps me to plan an outage and plan the replacement of those windings. As for categorizing different pulses and severity, our system comes with a pattern recognition system, whereas the pulses that are detected by the acquisition unit are actually analyzed for different parameters. And depending on those results, whether it's polarity, frequency, amplitude, length of the wavelength, it is categorized automatically into either ground wall discharge, void discharge, in-slot discharge, overhang discharge, and it creates categories. And every time a pulse comes in that resembles the previous pulses, it gets put into that category. So there's a buildup of pulses in that category over a predefined time period. And what we do is we look at those patterns and we see if there's any evolution telling us that there's something going on, other than also trending data and all kinds of other data. So we look at the trends, we look at each category, and we trend those to see if there's any evolution. And in reality, I guess many people don't know this, but if you have an increase in partial discharge, it means something. But if you have a decrease, serious decrease in partial discharge, that's much worse. It means theoretically that the voids are so big that partial discharge is not even possible anymore. Okay, so remember, partial discharge, you're measuring the partial discharge per se is in fact trying to determine how deteriorated my insulation is. You know, if there's no voids, there's no PD. But if the voids are so big, there's no PD. You can see that doesn't mean that no PD is a good idea. It means that there may be an issue. For example, if you have insulation problem near the neutrals, I mean, there's no voltage there, so there's no PD. So you might have a serious problem with your insulation near the neutrals, but it won't show up on the PD. And the same is true if you do offline testing. If you do offline testing, you excite the entire winding at the same voltage, and it's going to give you different results. I mean, it's a good idea to do that, but you can't compare your online data with your offline data because there definitely will be different. Okay?
All right, next question. We have a viewer who wants to know if their Zoom software will expire eventually, or if they can keep their version forever.
Forever is a big word. I can tell you that my 25 years at VibroSystM and I guess 10, 15 years at the technical support and software development department, I can tell you that VibroSystM spends a lot of money and time to try to make sure that new versions are compatible with existing equipment. The new software, when there's major changes, we usually offer the opportunity to send us your data so that we can convert it and make sure it's working correctly. We do not come up with new versions and simply abandon everybody. You have to buy our stuff. We do support software to some extent. I mean, we're not going to support software that's in DOS and was sold in 1989. But we do go to great lengths to try to accommodate our customers. And in some cases, when the technology is so old, for example, you bought your system in the late 80s, unfortunately, you have at some point the need to invest some money into getting new acquisition units and new software. And it's a good idea to do so because in reality, the investment is not that large. And of course, if you get new acquisition units and get new software, well, they'll be able to do a lot more than what you've been doing for 20 years. Higher speeds, better filters, better alarm functions, event triggers, conditional alarms, connection with SCADA systems, internet. There's a whole list of new functions that may be very interesting for you. So there are customers out there that have very old versions of the software and they still function, but for those who want to have new stuff, of course you need to adapt to the new versions and new equipment.
So I guess that this answers our next questions. Our next question in the same line of thought: is it necessary to upgrade hardware and software of systems used for monitoring and protection?
It depends how old your system is. We have upgraded software. For example, we had version 3 of the software. We jumped to version 5, 6, and 7. And all of these versions, to some extent, were able to connect to older, what we call vintage equipment, the equipment I used to install 20 years ago. To some extent, you can get a new version of the software and run the old acquisition units. Again, if you do that, though, you won't benefit from all the new features that are available. So if you go to an upgrade, looking at the price, you might find that it's not a much greater investment to actually change the acquisition units and get all the high-speed functions available. It will allow you to do a lot more than what you're doing at the present time.
We do have a very interesting question regarding vibration in hydro machines. Someone wants to know if it is required to monitor horizontal and vertical vibration. My guess is that it means axial and radial vibration in power plant and in hydropower plants.
Well, I mean, for me as an analyst, I never have enough information. So, for me, I would buy everything. But of course, I've never purchased a monitoring system, so it's not my money. We understand the fact that decisions have to be made. Budgets are available. You need to find out what you can invest in. When I consult with customers and we start looking at what do we want, in many cases the customer already has an idea what they want, and I usually ask them to let's just take a step back and first and foremost, what exactly are you trying to do? What exactly is your objective? I mean, and I know, if you talk to the mechanical engineers, well, we want some shaft displacement probes, some accelerometers on the bearing, and because that's their domain. That's what they do. And if you talk to the electrical engineers, well, they want some partial discharge, they want some flux probes, and that's normal. That's their domain. But if you have a certain amount of money and say, well, that's enough money to buy a flux probe, okay? Do you have a problem with the flux of your pole? Do you suspect anything? Or is it just a question of buying stuff to install and take a look? In many cases, unfortunately, people don't take the time to sit down and establish what's our objective. Where could we invest the least amount of money and get the most amount of return? And in some cases, depending on the history of the units, depending on the age of the units, the speed of the units, are they vertical, are they horizontal, are they 800 megawatts, are they 5 megawatts? All of these factors come into play to establish an objective. What exactly are we trying to do? Where do we want to be? And then determine, okay, should we go for shaft displacement probes? Should we replace our RTDs because we have 60 and 10 of them work? Temperature is a big issue on generators. There's very few failure mechanisms that do not generate heat somewhere. So if your temperature monitoring system is lacking, is suffering, investing in temperature probes definitely would be a good investment. But there's a whole list of other parameters, technologies that are available. Axial displacement can be important, especially if you had a thrust guide bearing failure. I've seen a few cases where rotors and turbines were not vertically positioned correctly. In some cases, the rotor was installed too high, so when they excite the unit, it actually applies pressure to the thrust guide bearing. Well, the only way to tell that is if you have an axial displacement probe that's actually looking at the clearance and seeing what happens. Because normally, most units, if you apply the field, the rotor is actually lifted up a little bit and it alleviates the pressure put on the thrust guide bearing. But if you don't reassemble it correctly and you do the opposite, your thrust guide bearing is not going to last for very long. So it depends what type of unit it is. If there's known issues, again, it's trying to establish what your objectives are, and only when that is settled, that you can actually make a plan of what to invest this year, next year, following year. Is it acquisition units? Is it new software? Is it new features? What exactly are you trying to do? And I think that's the best way to make sure that whatever you invest in will give you what you're looking for.
We have a more practical question here from Pradeep. He wants to know if our company offers on-site vibration monitoring system calibration. So he wants to know if we can go back and check the sensors.
Yes, we can. We can. In fact, the customers that have our ZoomWatch platform, ZoomWatch service contracts, which we're very happy to see that's very popular. Customers are renewing their contracts, so I guess we're doing something right. And that service comes with also remote maintenance, where our service department will take a look periodically to see the system is working correctly. And if not, we'll suggest either spare parts or replacement parts, or might suggest just maybe changing a cable or whatever is required to fix the issue. And in some cases, the department will go to site and actually fix the problem. Of course, as I mentioned earlier, our service department is very well qualified to install all the equipment we have, and in some instances connect existing equipment. In some cases, people have some inductive probes and they would like to keep them. Well, they can connect it to our system, no problem. And these technicians, these Zoom implementation experts, go to site and prepare all the installation, prepare all the commissioning, do all the testing required to show that the system is working correctly. And in some cases, they'll take a whole bunch of readings to give to my department so that we can take a look at the unit and give an assessment to the utility as to the health of their unit. Okay.
I think that is all for now, so we can continue with the questions gathered after the webinar.
Okay. One individual said, well, when we analyze data like rotor and stator shape and position, which is a rotor apparent circularity and concentricity, if we have abnormal results but not excessive heat or vibration, and I hear that a lot, from an operational point of view, we will say that everything is fine. But in some situations, should we act before having excessive heat or vibration? Or if so, what should we look at? Well, as I mentioned before, our philosophy, our objective is to detect issues and be able to act before there is damage. If we see a situation that is giving results that are beyond existing tolerances, and most of what we analyze, there are existing tolerances. Sometimes it's from ISO international standards, sometimes it's from CIATI. We have our own. I mean, a certain field of activity that we engage in is basically, we are the experts. So we have our own 34-year experience with these results. And some issues, depending on how severe it is, you can get away with. But if you have an issue in the unit and you say, well, let's wait till it heats up before we do anything, you're risking damage to the unit before you have a chance to intervene. I have a case we had in Canada where a unit had a thrust guide bearing failure, and they used the opportunity to put some air gap sensors and axial displacement probes, some shaft displacement probes, and during commissioning they took a whole bunch of readings, and the training on using the system was not given because all the employees, understandably so, had been working for like 3 months, 7 days a week, 12-hour days. And when the commissioning was done, everybody disappeared to take some well-earned rest and vacation. So nobody paid any attention to the results of the unit. And unfortunately, by the time everybody came back from vacation, the unit had failed again. And the data was sent to us, and you could clearly see the problem where the unit was installed, as I mentioned previously, was installed too high. And as they increased the load, more and more water pushing on the turbine, and it was causing tremendous pressure on the thrust guide bearing. But it still performed very well with no abnormal temperatures for a few weeks. And finally, when the bearing couldn't hold it anymore, the temperature increased dramatically very quickly and failed. Nobody had a chance to intervene. Now, if they had looked at the data and they would have seen that the axial displacement was excessive, they could have gone in there and find out why and fix the problem instead of failing the bearing again. And unfortunately, axial displacement, there's no real standard for that. Each machine is different. Manufacturer, I'm sure, has some criteria, but there's no absolute criteria. There's no ISO standard for vertical or axial movement. So they couldn't put alarms because there's no alarm value to put in there. So unfortunately, nobody was paying attention. Nobody knew what to look for. The machine failed again. So at some point, I understand, especially for large turbo generators, like in the nuclear field, it takes a lot of courage for an engineer to say, well, we have to stop this unit. You don't stop a 1,000 megawatt unit on a whim. I mean, you have to be sure that at least the data you have is sound, your reasoning for stopping the unit is sound, so that you can justify the risk and stop the unit and go and take a look. Because in some cases, you stop the unit and you go in there and you don't find anything. And not all problems will give you physical evidence that there's an issue, maybe not yet. We had a famous case in the US where they had old Westinghouse accelerometers on their windings. It was a turbo generator. And historically, the vibrations were fairly low. And when they did a major refurbishment, they ripped everything out of there and they put RF fiber optic accelerometers in there. And when they started the unit, the vibrations were much higher. And they stopped the unit a few times to see if there was any evidence of fretting, powdering, greasing, evidence that the windings were rubbing, or broken ties or loose ties, stuff like that. And they didn't find anything. And after looking at the data, we found that a lot of the vibration was low frequency, which the old Westinghouse sensors would not have picked up because they were tuned to pick up only the 120 hertz. So anything outside that range they didn't see, but that doesn't mean the vibration's not there. In the end, they put an additional sensor on the core. And what we found out is that the core was loose and the entire core was moving. So the fiber optic accelerometers were recording very high vibration, but in reality, the windings were not vibrating as opposed to the core. Everything was moving together. So there's no evidence of fretting because there's no fretting. The whole core was moving. So all they had to do is just fasten the core properly and the problem was resolved. And I had another case like that in Africa where they had a couple of phase lead cracks, failures. And we found by measuring the core vibration that actually the core was moving on one side, on the exciter end. Okay, so all this information, again, the more information you have, the better position you're in to actually eliminate possibilities or properly identify the source of a problem. And you do that, hopefully, before damage occurs. So it's important to look at the data and take the time to analyze this information. And in many cases, the utilities just don't have the resources or the experience, the expertise, which is why we came out with our ZoomWatch platform a few years ago, so that we can provide this type of information for companies who want to get the best out of their investment, but they just don't have the resources to do so. So they can rely on us periodically to go get the data, tell them what's going on, explain to them the trends we see, what we think they should be doing, maybe tweak this, tweak that, and it's much more cost effective to make adjustments than to replace parts. If you have high vibration of the bars and you can go in there and make them tighter, that's much more cost effective than to call the manufacturer and order some new windings because you just had a phase to ground failure, and hopefully you don't have to replace the core. So there's decisions to be made, investments to be made, but in reality, in many cases, the investment is not negligible, but the cost of not investing in it and having major failures is very high, potentially very high. Do we have any more questions?
Yes, we've received quite a few questions.
Okay.
Someone wants to know if it is possible to identify pole interturn shorts using air gap monitoring.
Interturn shorts.
I would be surprised.
Well, yeah. There's interturn shorts. This is for hydro generators, I assume.
Yes.
And there's interconnection. If you're looking for pole interconnections, the ones that are rigid have this tendency to fail, because especially if you cycle a rotor, the rotor will expand, will contract, and so forth, and that puts stress on the rigid interconnections, and they can often fail. In fact, they'll evaporate. The flexible ones are much better, but even those fail. And for that, the best thing to measure is the temperature of the interpole connections. And if you have a rotor with air gap sensors that you can identify as being a rotor that has adjacent poles which have varying radial positions, that puts additional stress on the interconnections. For shorted turns, the best thing to do is to use magnetic flux probes. But the magnetic flux probes will give you the maximum intensity recorded by the flux probe. Remember, closer the air gap, higher the intensity, greater the air gap, lower the intensity. So it's important to have an air gap sensor next to it that can tell you whether the variation that you're picking up on the flux is either caused by a variation in air gap. Like I said, the adjacent poles that are not at the same radial position, that will create a fluctuation in the flux, or if it's caused by shorted turns. But in reality, hydro machines, problems with shorted turns that cause issues are fairly rare. I actually wrote a paper a few years ago on that subject. It's common in the turbo industry, because the fact that the shorted turns in turbo industry is more of a problem, because if you do have some, it will create a thermal, I don't want to say misdistribution, but the thermal distribution of heat will be unequal. And that's going to cause, it's going to cause a change in the shape of the rotor. Now, a change of the shape of the rotor when you're running at 3,600 RPM, I guess you can imagine, creates tremendous vibration. Okay, so the issue is not the actual flux, it's the fact that if you have shorted turns on a turbogenerator rotor, it will bend, it will bow the rotor, and it will introduce vibrations. We don't have this issue on hydro generators. So to have a serious issue on hydro generators, you need a significant amount of shorted turns on at least one pole. And in fact, if you have one pole out of 80 that has some shorted turn issues, chances are it's not even going to show up on the vibration spectrum. Okay, so you need a major failure of the rotor itself, or you need multiple number of poles on, let's say, units that are high speed. They have less pole. If you have 50% shorted turns on 2 poles of a 12-pole machine, well, yeah, that's going to show up. I don't mean it's not a good idea to fix poles that have shorted turns. That's not what I mean. But the effects of it are rare. In fact, in most hydro generators, you can have 10% shorted turns on a pole, and it won't even show up on the flux. The flux will still be the same. So it's usually not that much of an issue on hydros.
I think we might have time for one last question today. Someone wants to know if the turbine vibration decreases on application of the field. We're talking about hydro machines. What could be the cause? So,
if the vibration at the turbine decreases?
At application of the field.
Well, the upper guide vibration usually decreases. That's what you want. That's what you hope for. Usually the vibration at the turbine is much lower. Usually the vibration at the turbine guide bearing is more in relation to the amount of water. You see a lot of machines that will have the vibration increase tremendously when you increase the load, hence the amount of water that flows through. I don't remember seeing a case where the turbine guide vibration decreased as we applied the fuel. Well, I mean, if the unit is well centered and the magnetic forces, of course, we're going to magnetically couple the rotor with the stator. I expect the vibration of the entire unit to go down, but it's usually more prevalent at the upper guide bearing or at the lower guide bearing than at the turbine guide bearing. Any more questions?
We have quite a lot of questions, actually. Some in Spanish, so I'm translating them right now.
Okay. Well, we'll keep them in mind, and then again, after the session is over, please, if you have any questions, comments, just type at the bottom of the page. We'll make sure we'll read all of them for sure, and all the comments and all the questions can be addressed in our future Q&A session, which we'll publish the dates shortly. But we can see that it generated a lot of interest today, so I think it will be a good thing for everyone involved to have another Q&A session. So please write all your questions, comments. Again, hydro generators, turbo generators, any parameter. It'll be a pleasure for us to take a look at that. If you'd like to have access to more technical content as we had today, don't forget to subscribe to our YouTube channel. You can click at the bottom at the icon on the right of the screen. You can also click on the bell on the upper right if you want to have notifications when new content is available. We will leave all videos on the channel permanently, so if you want to revisit this Q&A today or future Q&As, or if you want to look at quite a few, we've published, what, 13, 14 little video capsules on different subjects, so they're all on the site for you to look at. And I thank all of you for attending. I hope it was interesting. If there's any more questions, if there's a quick question, we have a few minutes. I know someone asked me the last time whether the magnetic and mechanical center issue is the same for horizontal. It's similar, but of course, horizontal units, you have an additional interesting factor to consider, and that's gravity. So gravity plays a role in both the rotor and stator. In some cases, rotor rims, if it's a vertical machine, you can get away with a loose rim. It's not what you want, but it might not cause an issue short term. But if you have a horizontal unit, gravity pushing and pulling on it will quickly deteriorate any kind of issue with the rotor rim. And for the stator, it's quite common to see the stators adopt an elliptical shape where 0 degrees and 180 degrees will have a much smaller air gap than on the sides because gravity is pushing on the stator. So it's putting a pressure on it, and it's quite common to see stators that are out of round on horizontal machines. Okay, so thank you all for attending. I hope it was interesting. Again, please don't hesitate to send us comments, questions at the bottom of the page, even after the session is over. We'll log all of these, and we'll address these and others, I'm sure, during our next Q&A session. So thank you, Bernard.
Thank you.
Did a good job.
Thank you, everyone.
And yep, take care. Stay safe.
Until next time.
Yep. Bye.